Hello everyone. Well, we're going to shift gears a little bit today. We've been um, going over a lot of vocabulary and concepts, definitions, terminology, and trying to get all that stuff reviewed and memorized. Today we're going to just solving good old-fashioned linear equations. Got several to do, several some really simple ones, and then some a little more involved. Let's get started. So these first ones we call one-step equations. Not a, they're fairly simple. One step and you've got it. First one, all you have to do is add 8 to both sides, right? Um, So I'm going to go ahead write that out, simply adding 8 to the left side, 23 plus 8 on the right. All we did was add 8 to both sides. We do that, of course, because we had a negative 8 there, right? We want to get n by itself, and this is how we do it. As you can see, negative 8 plus 8 is 0. And so the only thing left on the left side of the equation is n, which is what we wanted. We call this one step because right now there's only one extra thing on that side of the equation other than n itself. That's negative 8. So to get rid of it, so that n will be by itself, we add 8. If something's subtracted, you have to add that thing that's subtracted to both sides, and then it will cancel out and it'll be gone. So you have n, and over on the other side you have 23 plus 8. You obviously, of course, remember golden rule of algebra, you have to do it to both sides. Okay, so 23 plus 8 on the other side is 31. And that's it. Just gotta get my notes fixed over here on my other computer screen. Okay, so we're back. Okay, the next one, again, this is one step because there's only one other thing other than n on the left side, and that's 3. But the 3 is divided, so to get rid of it, we multiply. Okay? And so we will multiply both sides by 3. Okay, so on the 3's cancel, and it just leaves n equals, and 4 times 3 is 12. And that's it. Now I mentioned we can check these, right? In the first one, plug the plug 31 in for n in the original equation. 31 minus 8 is 23. Here you add 12 in for n. 12 over 3 is 4, just like it says. So they both check. We won't check all of these. If you have time, it's always a good idea on a test or quiz, just check them. Okay, multi-step, there's going to be more to do. There's a lot more on this left side than just one thing. On these kind, you have to look for what has to be simplified ahead of time or what has to be distributed. We're not ready to do anything yet until we distribute this, because we can't get rid of that 3. We can't get rid of the 6. We can't do anything because those things inside have to be multiplied by what's outside. Okay, so let's do that. Negative 3 times 6m, negative 18m. Negative 3 times negative 3 is positive 9. Okay, you have to do that step first. And now we can do some things. We can subtract 9 from both sides. Has to be both sides to get rid of this 9. And 9 minus 9 is 0. We are left with negative 18m on the left. 63 minus 9 is 54. We will now divide both sides by the negative 18. Now, some of these steps you could do in your head, but for a few of these, I'm going to write out most of the steps. Divide both sides by negative 18 to get rid of it, because we're multiplying by negative 18. To get rid of it, we divide. Of course, if you do it to one side, you have to do it to the other. I didn't leave quite enough room for this. We'll come over here. We have m equals, this is a positive divided by a negative. The result will be negative, and it's negative 3. That would be a good one to check. There's a lot of chances to make mistakes. When you check it, you can write it in. This is a good one to do in more detail. We won't do them all like this, but we'll write this in. We'll write it down, but just put, every time we see an m, we'll put in negative 3. So it's 6 times m's, but m is negative 3. And then write the rest of it. Minus 3 equals 63. And that should come out to be true. Now we have to do what's inside the parentheses first, right? And actually, I'm going to do the multiplication first here. 6 times negative 3 is negative 18 minus 3. So now we do what's in the parentheses. Negative 18 minus 3. That's negative 21. Put it in parentheses to make it clear. So we multiply negative 3 times negative 21. It's looking good because negative times a negative is positive, and it's 63 equals 63, so it checks. Okay, you could also sort of just check it in your head. Wanted to show writing it all out for that one. Okay, moving right along. Look at this. Again, we've got to distribute, right? So on the left-hand side, there's just 75. On the right-hand side, we're going to take the negative 5 and distribute it through. So negative 5 times negative 6p is 30p. Becomes positive because there's two negatives. Negative 5 times 3 is negative 15. Okay, so now it's like a 2 more steps. In this kind, you don't try to get rid of the p first, because you would have to divide by it, but you would have to divide both sides by it. You can't just divide 30p by p. You would have to divide 30p minus 15, that entire thing, by p, and that gets pretty messy. Okay. Oh, I'm saying that backwards. We're not getting rid of the p. Sorry, getting rid of 30. You would have to divide the whole side by 30. Sorry about that. So we don't want to get rid of the 30. It's too much work. In these kind, get rid of the thing that's subtracted or added first. So that's negative 15 this time. So 75. We're going to get rid of negative 15, so we add 15. Negative 15, add 15. Okay. On the left you get 90. On the right you get 30p, and that's it. Okay, now we will divide both sides by 30. When it gets down to the point where it's just something times p, that's when you divide to get rid of it. Left hand side divided by 30, right hand side divided by 30. On the left you have 90 over 30, which is 3. 3 equals P. Okay. Zip right through these. Then you could, of course, plug that in to check it. Okay, so we'll call this two-sided equations. They have x's on both sides, so it'll be a little bit more work. These others only had the variable on one side or the other, like this one right here had a variable over here on the right side but not on the left. If it has it on both sides, you have to get it so it's only on one side. You can go either way. We're going to get rid of either the 5x or the 3x, so only one side will have x's. So usually it's more convenient to be left with positive. These are both positive. We'll be subtracting. If we subtract 5x from both sides, we'll have a negative 2x over on the right. But if we subtract 3x from both sides, we'll have positive 2x on the left. So it'll be positive, and it makes it a little easier at the end. So we're going to subtract 3x from both sides, and I'll do it this way. I'm just going to write 5x minus 6 minus 3x up there on top, and down here 3x. You can do this either way. You can write it right next to it like this and just insert it in there. Okay, or you could write it down exactly as it is, and then at the end write minus 3x. I think I'll be doing them that way this time. Writing it at the end lets you go back and look and easily check if you made any errors, because you can see 5x minus 6, 5x minus 6. I didn't mess that up. I subtracted 3x from that side. Over here, I have 3x minus 4, I have 3x minus 4. I didn't miscopy, and I subtracted 3x. So I have subtracted 3x from both sides. It's easy to see that because everything else is in the same order it was. So I'll do them that way. So on the left we have 5x minus 3x. They're not next to each other, but you can still subtract that. 5x minus 3x is 2x minus 6 equals, now you have 3x minus 3x. That's 0, and you have negative 4 here. So we do have more steps because we're still not done. Now we have to get the 2x by itself. And again, I'll just mention again, if you have trouble remembering, do I divide by the 2 to get rid of it? Do I do that first, or do I add 6 to both sides to get rid of it? Do I do that first? Whenever you're not sure, think about it. If you wanted to get rid of the 2, you have to divide both sides by 2, the entire side. It would look like this: 2x minus 6 divided by 2, right? The whole thing. And that's a legal step. You can divide the whole side by 2, but then you would have to split this up, and that you may not even recognize how to do that. Don't worry about it, because this isn't the best way to do the problem. But this would be 2x over 2 minus 6 over 2, negative 4 over 2. We're lucky that 6 over 2 is a whole number. So in this case, this would work pretty well. We could do it. But usually this will be something like 8 over 3, or something that doesn't just go to a whole number. Just for fun, since this one didn't cause us any problems, we'll go ahead and get the answer. This is x minus 3 equals -2. Then add 3 to both sides and you get x equals 1. We'll see if we get the same thing doing it the shorter way, which is adding 6 to both sides, right? And I didn't leave myself a lot of room here, so I'm going to have to kind of squeeze this in there. Maybe I'll move this next one down just a little. Show off my cool lasso. Move it down a little bit. Now I'm going to have a tight squeeze on the next one. That's okay. So, yeah. This is 2x minus 6. We're going to add 6 to both sides. So we get 2x on the left. The -6 plus 6 goes away, goes to 0. 2x equals 2. And then we have divide both sides by 2 here. And I will just sort of do that step in our head. Divide both sides by 2, x equals 1. Okay? So, yeah, we got the same thing. We got x equals 1 over here as well. From that point, from this point right here, the way we did it took 1, 2, 3 steps. This other way would have taken, in this case, 1, 2, 3, maybe 4 steps, not a lot longer. But the only reason it worked as well as it did was this was a whole number. So, that just shows, yeah, you follow the rules of algebra, divide both sides, the entire side, by 2, and if you do it right and don't make mistakes, you can get the answer. But don't do that. Not as efficient. Sometimes it's a lot messier when this fraction is not something simple. Instead, at this point, add the 6 to both sides. Okay. Go ahead and take that off of there. Okay, so here's a long one. A lot of simplification to do there before we do anything else. You distribute wherever you see something times something in parentheses, and you also gather the like terms and go ahead and combine them, right? Like terms can be combined. So over here, I'm 12x negative 6 times 2x negative 12x, and then it's positive 3. Watch when you distribute, negative 6 times negative 3. Oh, not positive 3 though. Negative 6 times negative 3 is positive 18. Over here we got to combine negative 10x minus 2x negative 12x plus 20. Okay. Now we got more to combine, right? Over on the left, whenever you see a lot of terms go, okay, we only have 2 kinds of terms in these, right? We have constant terms, which don't have a variable, and we have the x terms, which have the variable x. So if you have 3 things on one side of the equation, there's only 2 kinds of things. There's going to be extra of one of those things, right? So you have to be able to combine. 2 and 18 combine to 20. Okay. So, This is looking kind of interesting. Looks kind of the same on both sides, huh? But let's do the drill. We want to get rid of x from one side or the other. So to get rid of x from the left side, we would add 12x to both sides. Somehow we have a feeling that's going to get rid of it on both sides, right? So over here on the end, I'll just add 12x over here. Plus 12x. There's lots of different ways to write that down, right? When you're adding that, you can do a shorthand and just write it down below. Because I think we have quite a few students will have a little bit of trouble with this, so I'm doing it this way. So I think it shows more clearly exactly what's going on. So, oh, I wrote plus 2x. That's plus 12x. Squeeze that in. Both sides, I did the same mistake. Sorry about that. So we add 12x to both sides, and negative 12x plus 12x is 0. It leaves 20 on this side. Over here, negative 12x plus 12x is 0. Also leaves 20. We're left with this. You may recall what to do in this situation. Main thing is think logically. These are all equivalent equations because we followed the rules of algebra. And when you follow the rules of algebra, all the equations are equivalent, which means they have the same solutions. And that's how we get to the end and we say x equals 1. And we know that all the equations have that solution, including the first one. So we say we've solved it. X equals 1. Well, what are the solutions of this bottom equation? Because whatever they are also the solution of the one we're trying to solve. What values of x would make this true? And the first reaction often is, well, no values of x make it true. But people think that because there aren't any x's in it. But that's not really the question. The question is, for what values of x is this true? Let me say it that way. Well, I think this is true for all values of x, right? In fact, because it does not have an x in it, x cannot wreck this equation. It's just straight up true, no matter what x is, okay? Which means all real numbers are a solution for this equation, and all real numbers are a solution for the original equation because they're equivalent equations and have the same solutions. So we could write all real numbers. Whenever you have a situation like this, maybe you'll remember all real numbers, but if you don't remember, stop and think. Okay, 20 equals 20. That's always true. So no matter what x is, that's true. And so all real numbers are a solution. It can also be written like that. It's a special symbol that means all real numbers. So you can write it either way. That's it. Okay. We got one more. This is the one I'm going to have to really squeeze everything in. Let's see. So let's go. So we distribute 2u and then negative 20 and equals 0. So I took 2 times u is 2u, 2 times negative 10 is negative 20. We got things to combine. There's a lot of terms here. Got to be able to combine something. 8u and 2u is 10u. Minus 20 equals 0. Add the 20 to both sides. And we'll do this one in our head, where you don't have much room. When we add 20 to the left, of course, it cancels with the negative 20. And so it gets rid of it from there. So we have 10u equals, and we added 20 to both sides, 10u equals 20, right? Because it didn't have anything. It just had 0 on the right. Now it has 20. And we'll cheat a little bit. Write it up here. Divide both sides by 10. We'll go ahead and write that step. Now that we have room, because we moved to the top. 10u equals 20, but divide both sides by 10. So u equals 20 divided by 10. That's 2. And that's it. To check it, plug it in. We can check this one pretty quick in our head. Put in a 2 for the u right there. 2 minus 10 is negative 8. Take that times 2, that's negative 16, right? So keep in mind that that whole thing's negative 16. Over here we have 8u, 8, which if we plug in 2, that's 8 times 2, that's positive 16. So positive 16, we said this was negative 16. Add them together, you get 0. Okay, we're going to now look at a special kind of equation called proportions. And proportions are just equations that have two fractions set equal to each other, and that's it. Fractions actually can represent ratios, and proportion is defined as an equation where two ratios are equal. Okay, but ratios can be written as fractions, so it's when two fractions are equal. The trick you have to remember with proportions is you cross multiply. That gives you two products, right? Product to me is what you get when you multiply. So when you cross multiply, which means diagonally, the 4 times the 8 and the 6 times 5m. Set those two products equal to each other and then solve that. So take 4 times 8 is 32. 6 times 5m we'll write like this. Okay, so the point about cross multiplying is that's a step that you can always do without changing the solutions. Okay, and so it's the easiest way to start these problems out, because now we have a problem. It's more like we want. I need to back up a second though. After you cross multiply, often you'll have some simplifying to do. So look for that. So the left side's 32, and on the right we've got 6 times this quantity 5m, but multiplication is associative, and all this is doing is multiplying, right? 6 times 5m grouped together, but you can change the grouping. So we can take the 6 times 5, and that's 30, and then take that times m. So that's what we do, and now we divide both sides by 30. This is one I won't go ahead and write out. So 32 over 30 equals, and on the right side when you divide both sides by 30 you just get m. We do have to reduce that. I'm having trouble seeing my notes. Sorry about that. I just wanted to make sure I got this right. Okay. Yeah. And it's a kind of a messy fraction. It has to be reduced, right? We'll bring it up here. 32 over 30. You can divide both of those by 2, and that gets you 16 over 15 equals m. Okay, one more proportion. This is a very common type of problem. And you cross multiply just like the one we just did, but you have to be careful when you cross multiply that. You take n plus 10 times 8, you have to take the entire thing n plus 10 times 8. You can't multiply just the n. That would be a common mistake, but don't do it. Remember, the bar is a grouping symbol. It's just as though you had parentheses around n plus 10. So when you take 8 times the numerator, you write it down like this: 8 times n plus 10. Okay? And the other one is 3 times, in parentheses, n plus 6. Parentheses have to be there. Because that fraction, what's the numerator of that fraction? It's n plus 10. So the n plus 10 is what has to be multiplied by 8. Put it in parentheses. The same with the other one. So we multiply this out. 8n plus 80 equals 3n plus 18. All we did was distribute. Now it's just like when we did a while ago. We're going to subtract 3n from both sides. I'll do this part in our head, so to speak. We subtract 3n from both sides. Over here, 8n minus 3n is 5n. We'll leave everything else alone. Okay. Now we need to get the n by itself, but first we're going to get 5n by itself, right? We don't worry about the 5 till the end, as we talked about a while ago. So we subtract 80 from both sides. And we'll do this one without writing it down. Minus 80. We'll just do the subtraction on the left. The 80 goes away, of course, because it's 80 minus 80. On the right, it's 18 minus 80. Well, when we say we're doing it in our head, maybe we're not going to quite do it in our head. We're going to write that down just so we don't get confused. 18 minus 80. Okay, 20 minus 80 would be negative 60. So this is negative 62. And all we have left is divide both sides by 5. You can just write that right here. Divided by 5, divided by 5. But when you look at it later, that step where we had 5n equals negative 62, where's that step? Now we have this fraction and fraction. The 5n equals negative 62 is gone. I think just so that you can look back over it later, I really suggest leaving that there. Writing another step over here. 5n equals 5. Let's see. 5n negative 62, dividing both sides by 5, which leaves n equals negative 62 over 5. You cannot reduce that. Okay, you can punch it into your calculator if you want, that's fine. But there's no common factors to reduce. Okay, now we get to everybody's favorite problems when solving equations, and that's solving for a variable. People don't like these. I'm not sure why. I think they're kind of fun. We are solving this for a specific variable that they tell to solve for. Okay, so the first one they say solve for h. Well, you might say, why solve for h? There's an a in there, capital A, there's a b, there's variables all over the place. Why do we care? Well, we care because they told us to solve for h. It's a good exercise. Sometimes this is actually a very useful process. You might have a formula like this one gives you A, which is area of a triangle, in terms of B and H, the base and the height. But you might want to have that in a form where you find out what the H is in terms of the area and the base. Maybe you can find out the area, or you know the area and you know the base, and you want to quickly calculate the height. And so you would like to have height equals and have A for area and B for base on the other side of the equation. It just might be more convenient. And actually people do this all the time in science and engineering. They solve for a particular variable that gives them a formula that they can use to calculate that variable. So the formula as it's stated right now lets us calculate area if we know base and height, but again, maybe we know area and base and we want to calculate height. So let's go. Solving these is just like the other kind, guys. It is exactly like what we do with numbers, except there aren't as many numbers, there's letters. But other than that, you do it exactly the same. If we want to solve for h, we need to get rid of the 2, okay, and we need to get rid of the b. Think of the 2 as being divided by, right? I'm going to look at it that way. This is b times h is in the numerator and 2 is in the denominator. So I'll just write it down over here to show you what I mean. This could be written a equals bh over 2. That's the same thing. Okay, a half bh is the same as bh over 2. As multiplying by a half is the same as dividing by 2 is one way to look at it. So that's what you've got. 2 is in the denominator, and you think about, you multiply this out, numerator times numerator, denominator times denominator, right? So bh are in the numerator, and so is 1. Multiply that, and you get bh on the numerator. Denominator is just 2 in the fraction 1/2. The denominator of these, if we wrote the denominator of the others, it would be 1. So you got 2 times 1 times 1. So hopefully you're comfortable with saying, yeah, that is the same as this. Okay, so we want to solve for h. So this 2 is in the denominator, so we multiply both sides by 2. Okay, so this time I'm going to go ahead and write that step out. 2 times a equals, we'll write the 2 out front, 2 times 1/2 bh. And this step will get rid of that 2. Remember, we're trying to get h by itself. So on the left we have 2a. On the right, the 2's cancel, we have bh. So we're closer. Okay, now we just have to get rid of the b. So divide both sides by b, right? You see, this is exactly how you solve the other problems. Divide both sides by b. Okay, that's h there, a little messy. Okay, so on the left you have 2a over b. On the right you have only, the b's cancel, you have only h, which is what we were trying to get. So we have solved for h in terms of the other variables. Okay, it's 2a over b. Who knew? You may recognize this area formula for a triangle. Area equals 1/2 the base times the height. Turns out the height equals 2 times the area divided by the base. Okay. So next one. Solve this for y. Okay. So this is, we see this 2 on the bottom, so it's going to start out like the other one. We can't get rid of any of this other stuff. We need to solve for y, but we can't get rid of the 1. It's grouped, and we could write these parentheses in here. Remember, the bar is a grouping symbol. We can't do anything inside the parentheses, so the first thing we do is get rid of the 2, multiply both sides by 2. So we'll do that in our head. On the left it will just cancel and leave 3y minus 1. On the right we'll have 2x. Okay, so we got rid of the 2. We're wanting to solve for y. Next thing is to add the 1 to both sides, right? Add 1 to the left hand side. Yeah, this time I'll write it out. I have enough room. 3y minus 1 plus 1, added on there, equals 2x plus 1. Added it to both sides. The negative 1 and 1 is 0, leaving 3y here. Over here, 2x plus 1. We're almost done. All we have to do now is divide both sides by 3. So you could write it like that. And then this one takes a little more work, because on the left now we have y just like we wanted. We've just about finished solving for y. We have on the right 2x plus 1 over 3. Generally, you want to have it with a coefficient of x and then a constant term, and we don't have that now. So this is a good exercise, a good thing to look at. You have to split this up as 2x over 3 and 1 over 3. Okay, so this is going backwards from the good old-fashioned rule of how you add fractions, right? You add two fractions, and let's just look at numbers. You have two fractions with the same denominator, 2/7 plus 1/7. You combine that, and 2 and 1 is 3, and you just write 3/7. But what you've really done is you took 2 plus 1 over 7, right? This is what we do all the time. Since you learned how to add fractions, you did these over and over, right? Well, you could also do this backwards. 2 plus 1 over 7 is 2 over 7 plus 1 over 7. So that's what we've done here. 2x plus 1 over 3, well, that's 2x over 3 plus 1 over 3. Okay, that's how fractions work. You have a common denominator here of 3. At this step we just arrived at, common denominator is 3, so you can add the numerators, right? 2x plus 1. Except that's the less advantageous form up there. We want one of the terms to have x and one of the terms to not have x. And up there, it's all just one big jumbled quotient where you take 2x plus 1 in the numerator and divide by 3. So this is the... I'm really, for this problem, there's nothing wrong with leaving it that way. You've solved for y. I don't see any problem with this. If you want to leave it like that, that's fine, because the problem just says solve for y. And after all, what's this doing? There we go. You did solve for y right here, right? You have y equals and all the other variables and so on. In this case, x is the only other variable. That's good enough. But this is probably the way it's usually going to be written in a textbook or something. So I'll put the box around this one. Either one is really okay. All right, couple more. Next one says solve this for y. Get the y by itself, just like a regular problem. I'm going to subtract 3 from both sides. So on the left, it'll just leave y over m. On the right, it'll leave n minus 3. Almost done. Multiply both sides by m. I'll write this one out this time. Y over m times m equals n minus 3 times m. And over here on the left, you just get y, and on the right, you can write it in either order. The n minus 3 has to stay in the parentheses times m. Or you could write the m out front, and then n minus 3. Either way, Not so bad, right? I think people just look at all the letters and they go, I don't know how to do that. But I think you do. They're just like the others. It's just that you have letters instead of numbers. Okay. Next one says solve for x. Get the x by itself. We have something else with the x over here on the left. Again, you can't get rid of the 5 yet. You could, but it would be really awkward. You'd have to divide the entire side by 5. So we're going to end up dividing by actually -5, but we will do that when the only thing sitting there is the -5x. And then when we say divide the entire side by -5, it's real simple. So to get to that, subtract 2y from both sides. You're left with -5x equals 7 minus 2y. Okay, now we want to solve for x, so divide both sides by -5. Okay, on the left you have x. And again, this is one of those, let's see how it is in my notes. Yeah, that you could split that up, but you don't really have to. So we would split that up as -7/5, because 7 over -5 can be written -7/5. And then you would have plus, because you could write plus -2y over -5, but that's kind of unnecessarily complicated, right? So the negatives cancel, and you just call it plus 2y over 5. 7/5 plus 2y over 5, or oh, did I? -5. Okay, I want to make sure I get this sign right, sorry. 7 minus 2y divided by -5. So it's +7 over -5 is this, but -2 over -5. So yeah, if you did split it up, you would get this, or you could leave it like this. Oh, I didn't leave it like that. The other way to write it would be x equals 7 minus 2y over -5. Okay. So that's the last one. And you know, those aren't too bad. Your homework is on Canvas, so you can see it there. And that's all for now.